Hey everybody, I was just getting ready to grind the bead on that Hendey lathe leg and go over an issue that I discovered with that. But first, I wanted to show you this. No, not the grow light, the bench. Yes, for those of you who follow my channel regularly, I have sold the Atlas lathe. I was very happy to see that go to a new home because I was on the verge of possibly parting it out, which would have probably helped out a lot of other people with broken parts on their early Atlas lathe. But the reality is that it would have taken me a long time to sell off all the parts and get the money out of it. And furthermore, the other issue is there are probably some parts on there I never would have been able to sell. I probably would have ended up with the bed going to the scrapyard, which is a shame because that was a 54-inch bed on that one, which was nice. Good length. But anyways, so it's got a new owner. The gentleman came all the way out from Western Massachusetts. When he told me where he came from, I was surprised, but he had said that he had been looking for a while for a lathe that size. The great thing about it was he basically came down. We went over, what came with the lathe and everything. Did a quick couple of test cuts there, and he was satisfied and just didn't even bother trying to, bargain me down. Paid me my full asking price, which is great. So it took a little longer, but then again, I did first put it up on Craigslist like 2 weeks before Christmas, which is not a great time to post something unless it's going to be a Christmas gift. So the Atlas lathe is no more. Maybe I'll probably have to include a copy of this little video, maybe as a clip, to just close out the playlist for the Atlas lathe. All right, so back to the matter at hand. The Hendey leg, in either part 51 or part 52 when it was posted. One of my viewers commented with a question, and he asked why I didn't just bolt the broken pieces down to a metal plate to keep them fixed in position so that they would, stay exactly where I wanted them to, instead of what I ended up doing, I ended up clamping it with a pony clamp. Those of you guys who saw the pony clamp on there probably got a good chuckle out of that. My reply to him was that, I was laying this down on the tabletop of the welding table, which was a good flat surface, so I figured it was okay. In other words, my Nomad welding table there has got a nice flat surface on the top there, and I kind of had it partially held down with the clamp that you see right here, a hold down. And then with the pony clamp on there, I thought, well, okay. What I failed to take into account, which was really silly on my part because I've known about this issue, is the warpage of the casting as it's being heated during the welding process. So his point was bolt it down to a plate, I guess, to keep it from being able to really move when it wants to try and warp. Didn't do that. At some point during the welding process, it must have decided to warp and move, because now I haven't ground the bead on this yet, but here's what we got going. Okay. Now, this is on my workbench, so it's not, going to give me an exact, but I mean, there's definitely an issue here. Sending out an SOS. Anyways, I can put this on my cast iron surface plate and play around with it and get some exact measurements. But the point is, I've got this issue now. So I don't think, because it's cast iron and the nature of the beast, I don't think it's going to flex enough that when I put the weight on it, that it's going to be happy. I think what is more than likely going to happen is when I put the weight of the bed on it, I think there's a very high possibility that it's going to end up cracking again, because I'm going to basically, if it doesn't crack right away, it's probably going to still be in a stressed state. So I'm not quite sure how I'm going to handle this yet. And that's basically, I'm going to leave this video. We're just going to grind it. We're going to take a look at it, maybe talk about it a little bit more. And then I'm going to post the video, and we're going to see whether or not we get some comments there in the comments section to help guide me as to where to go next. Oh yeah, other people suggested that I should just, if this is going to be a working lathe, a usable lathe, that I should just have this piece recast. Well, yeah, I mean, if money was no object, if money was no object, then that's exactly what I would do. I would have not even touched this. I would have taken the two pieces so that, you know, you had a nice clean break, and sent them out, and somebody would have used this as a pattern to cast me a new piece. Not quite sure how that works either, because you got to take into account shrinkage, as George Costanza would say. Shrinkage! Anyways, that being said, here's a couple of ideas I had for fixing this. I'd like to know what you guys think. Option number one would be I just clean up the grinds here and I install it the way it is and see what happens. Will it over time deflect enough and actually come back into shape? Or will it crack immediately? Or when I go to bolt it down to everything and try and pull it in, will it then crack? I got a feeling it would crack if I did that. So that's not really an option. Option number two would be that I use the Wells Index mill with use of a fly cutter or a face mill, actually clean up the top of this and take the bow out. Now the trick there is, technically it's bowed, it's out of alignment on two planes. This plane and the Jefferson airplane. I mean the bottom plane here. So the problem is that if I just anchor down one side here and let the other side float and come across and mill this, well, then this is going to be a perfectly level plane that is going to be out of parallel with the bottom. All right. So what I would probably do if I decided to go that route is I would probably mount it in the mill. First, I'd put it on my surface plate, and I'd determine exactly how high the high spot is. In other words, it's not rocking in this axis from this corner to that corner. It's definitely rocking in this axis from this corner to this corner. So what I'm thinking is, if I can determine when this is pushed down to the plate and making contact with the plate, determine how high this corner is. Split the difference and shim both this corner and that corner the amount that it's out. Okay? Then mount it in the mill that way on the table of the mill. Then clean up the top. Get myself a good clean surface that's all in one plane. Flip it over, take the shims out, put this surface down on the table, and then come across and mill this surface. Okay? So there's that. But then the interesting thing about that is, now that I think about it, is that really there's two surfaces here. That obviously is because of the ugly bead that we've got on there. Which brings up the question, I haven't actually verified whether or not this surface has got an issue. I assume it would have to, but what we'll do is clean up the bead on that, and we'll put it on the surface plate and see what it acts like. So the reason why I talk about, well, there's two surfaces here is because, well, maybe I can mill out the high spot on just one of these two surfaces. I don't know about that either. I could probably do that. If I clean up the bead and that sits that way on the plate, no problem, then yeah, that's a no-brainer. We just clean up that one. I also have to take into account that milling off any of this material is going to shorten this leg. So, milling off any material is going to shorten this leg. This is going to have the effect of dropping the headstock end of the lathe down. So, let's just look at the Vernon for sake of argument. So, what's going to happen is that's going to drop the headstock end down. Now, it should be a very small amount, but you know what? We're talking about thousandths of an inch in the stuff we're dealing with. So, you know, a small amount can be a relative term. All right, so I apologize ahead of time for the crudeness of this mock-up, but bear with me. Let's pretend that these are the two pan legs, okay? And they should be the same height. And let's pretend this is the bed of the lathe. So, in effect, what we've got is a situation that if I shorten this leg, if we shorten the height of this block, what effectively happens is that's going to drop this end of the bed down. Now, for the purposes of our discussion here, I'm going to exaggerate that. So, there's my dropping the leg down. And what we're looking at that's interesting is what's happening over here now at this tailstock end leg, okay? By dropping that end down, we've now created a situation where this edge wants to lift up off of the pan leg. But it can't because it's putting stress on, it can't because it's bolted to it, like so. So essentially what's happening is the bed is going to be putting force on this outside edge of the pan leg, and that's going to be putting stresses in there we don't want. Either that, or what's going to happen is, because the bed is so long, even though it's cast iron, it will actually have a little bit of a ability to sag, or bow in this case. Okay, so even if this doesn't put stress over here, you could end up with a situation where the whole bed actually wants to dip down. Now, this is greatly exaggerated naturally. What I'm thinking is either one or two things. Either because of the length of the bed, the distance between these feet, that the small amount, let's say I drop this this end of the bed, a 1/16 of an inch, which is quite a bit. But let's say that warp, that after I face both sides in the mill, that I end up effectively taking an overall 1/16 of an inch off of the height of this. Will a 1/16 of an inch over here, drop over here, really translate to that much of a difference all the way over here? Because don't forget, I mean, you could see I've dropped this half the distance. This is a 1, 2, 3 block. So I'm going from, when I go from 2 inches to 1 inch over here, okay, a 50% reduction in height on this end only translates to that distance right there on this end. So in other words, it's the error is not amplified, it's actually minimized the longer the bed is. So in other words, if we had, if the bed was really short, you can see now that creates a bigger problem. You can actually see that gap gets bigger, but the further out we come, the less critical this is. Or the less error ends up happening here due to here. So that's why I might be able to completely ignore it. The other thing I can do is if I do end up actually shortening that leg by, say, an overall 1/16 of an inch or whatever it ends up being, I can make a plate to sit underneath the leg between the pan and the leg, which will lift it up and effectively eliminate the issue altogether. So in other words, basically put a plate in here to make up this size here and effectively create the situation we started with. So that's an option there. Safety glasses. All right, here's what it looks like after cleanup. You can see there's still quite a few craters in there. And I could get my other stone with the cone shape to it, gouge out these little areas, and then come back and flow yet another bead over the top of this. This area right here is really kind of lousy, but I really kind of shied away from that only because that's where I was having the problem with the cracking before. This is going to be hidden. I know I said I don't care what it looks like, that I'm not going to do any more on this, but boy, this ended up really being a real big crater area here that I had to grind out. And here too. So I'm tempted to maybe yet again run another bead. Oh, right here too. This is what I was thinking, right in there. But it's a lot of work to go through for something that, in reality, this sits under the headstock end of the bed. When the headstock and all the gear train is on, it's pretty hard to see this. And once this is cleaned up and painted, I mean, yeah, if you're looking to win some awards, it's going to look like hell, and you're not gonna place. But important thing is no cracks visible. So I got a couple arc strikes there. I don't know how I did that. I must have been clamped there, and it must have been arcing. The clamp must have been that would be a good indicator that I wasn't getting a good ground sometimes, and that might have been why I was having some trouble with the arc. Not the Ark of the Covenant so much, but So let me just clean that up real quick. I've got this, I think I've got this pretty good as far as being able to now put it on the angle plate and test that side for flatness. Wow, the shizzle my nizzle. This is interesting. Anyways, I'll have to put it on the surface plate and take some measurements with some feeler gauges, but definitely that's rocking a lot more than that. Well, here's a good example of why you shouldn't trust your tabletop. Now that I put it on my cast iron surface plate, it does rock significantly on the side that we already knew about, and also significantly on the side that I thought seemed better. So there must have been just an unevenness somewhere in the table and the way I put it down. Let's figure out exactly how much of a rocking and rolling we got here. Alright, so I've got some assorted feeler gauges that were taken out of their holder, and it seems like every time I find buy a toolbox, there's a couple of these. And at any given time, several of them. I kind of put them together in a pile and kept them handy. So this would be 52 thousandths. I'm just checking to see if when I push down on this side over here and rock it back, whether or not I can get this in there without too much force. Alright, that's not rocking now. So I think 52 thousandths does it. Now I just want to check for giggles and see if when I try and put a smaller one like this one, which is only 5 thousandths, try and put this in, actually this is 6 thousandths, try and put it in on this side Will it go in? No, it won't. That's good. That indicates to me that this side is sitting flat down on the plate, which is what I want. Then if I split that in half, 26 thousandths, technically I should be able to put 26 thousandths under this corner and 26 thousandths under this corner, and it shouldn't rock. I just redid this because it's kind of tricky, because I want to get in I want to get to the point where the stack is just under the edge, because if I push it in too far, I'm actually wedging this up even further. So the further in I push this, the more of an effect, a lifting effect I'm getting. So I want to be right on that very edge there. So with the 52 thousandths in there, there's still a rock in there. And if I put in my next smallest one I have handy, which is a 6 thousandths, I actually can't get that in there freely. So we're somewhere between 52 and 56 thousandths, and I'm not going to split hairs at this point. So if I go with splitting, say, 54 thousandths, that would be 27 thousandths on each side. Now I know I said 27 thousandths, but I had a stack that adds up to 28 thousandths. So I put the 28 thousandths onto this side. So if I wanted 27 on both sides and I've got 28 over here, then I should be at about 26 thousandths on the other side. Now I have a 20 thousandths shim, and it's still going to rock, which is what I would expect. So let's see how much we've got under there. Still kind of a tight fit, even at 24 thousandths. That might be, I might have the stack on this side pushed under a little too far. So let me see if I can better explain what the hell I'm doing here, what my whole point of this exercise is with the feeler gauges and everything. Right now, because of the wobble, if I try and clamp this down, first of all, I can't really clamp this down properly without possibly even putting enough stress on it to crack it. So if I just clamp down on this side, for instance, and I clamp this down firmly, this side will actually be floating. So I would have to shim under here anyways to give it some support. Okay? So if I shim this up, I don't want to shim it up too high. If I shim it up just enough so that it's supported underneath here, and it's firm, and I clamp it all down to the table, and then I come along with the milling cutter, the face mill. Let's pretend that this scale right here is the plane of the face mill as it's coming across the top, and it's making its cut going across the top. If I do what I just said, what ends up happening is this ends up being the high spot. This ends up being 50, what did I figure, 56 thousandths high or something like that. I just already forgot it, but this ends up being the high spot, and it's high by 56 thousandths. So the cutter's going to come by. I come from this side, and the cutter's going to come by, and it's going to take a full 56 thousandths right here at this edge. But as it goes across and gets over here, it's going to be taking nothing. Okay? So I'll be taking off 56 thousandths here and nothing over here. I also, because this is the high spot and this is the low spot, as I move the cutter this way, it's going to take less here. It's going to take the least amount here. This is my low spot. So it's going to actually I probably would take a little bit here. The point I'm making is, in order for me to get to a point where I'm able to make this one plane, okay, one even plane, take out that warp, I would have to take a minimum of 56 thousandths cut. That drops 56 thousandths height from the leg. And when I finish, I still have the other side warped. So then I got to flip it over, put my new face down on the table, not shimmed, because now it's a good all-in-one plane. And then I've got to correct that other side, and I might have to take another 56 thousandths. So by the time I get done with both sides, I've taken over 100 thousandths off the height of this. Whereas if I shim it before I clamp it down in a fashion so that I only raise this up half of the 56, or roughly, 26 thousandths. And then of course I put about the same amount under here, so that I've essentially got this thing like halfway between the point where this is down and halfway between the point where this is down. Okay? Now I can come across and the cutter will take a little bit off of here. Okay? At some point in the middle it should take very little, and then it should start taking again as it moves towards this side. And I should be able to take the warp out of this side without having to take off more than 26 thousandths or so, or like half the amount of material. Now if I do, then when I flip it over, if I do the same thing for the other side, effectively I might be able to get away with not having to take more than 60 thousandths off the entire height of this thing. What's going to effectively end up happening is we're going to actually end up lowering the position of this hole by 26 thousandths, say, and then we'll also end up lowering the headstock's position, the bottom of the headstock's, the bottom of the bed, which has the headstock sitting on top of it. The relationship between that dimension from the center line of this hole to that will also change by 26 thousandths. I don't think that's going to be an issue, because the rod that goes through here actually goes into a lever that's got a U-shaped slot in it that catches a piece that it moves back and forth. So by design, that's already got some play worked into it, some fudge factor, because what happens is as that U-shaped piece turns like this and actuates the part underneath there, what ends up happening is it actually has to change. There's a dimensional change there anyways, for lack of a better term. So that's where we stand. So I'd be interested to know what you guys think of that plan. I wish I had a surface grinder, because if I had a surface grinder, I would probably do this operation on a surface grinder. That being said, if I wanted to, I guess I could clean up one side completely so that it lays flat, and then clean up the other side till I'm close, and then send it to a shop that has a surface grinder and have them do it for me. But that's an extra added expense I really didn't plan on. So I don't know. I think because it's cast iron, and we're not talking about a machined surface here. This is just a leg to support the bed. It's actually a pretty rough. It's kind of rough anyways. So I don't think that was ever. I think even when this was made, I don't think this ever was ground. No, well, maybe it was. I don't know. That's where we stand. So I'm going to wrap up this episode right here and wait to hear from you guys. If you have some constructive comments or criticisms, you're welcome to leave them. Oh yeah, I almost forgot my call to action. If you like what you see, please subscribe, and thumbs ups are also appreciated. Take care. That sounds stupid.